Now the next thing that we have to understand and learn is quadrilaterals. They have to be divided very clearly into parts like this. One is the parallelogram, okay, and the other one is trapezium. Okay, let's try to understand them. And then there are some general quadrilaterals which are neither parallelogram nor trapezium. First of all, parallelogram. I'll draw a parallelogram as simply as possible. If I have this A, B, C, D as a parallelogram, then what are the properties? Very clearly, AB should be parallel to CD, AB should be equal to CD, right? Similarly, AD should be parallel to BC and AD should be equal to BC, right? Now here, any pair of information given should be sufficient to tell us whether ABCD is parallelogram or not. For example, only this set of information is sufficient to tell us, right, that we don't need to check the other pair, or only this set of information is sufficient to tell us that it is a parallelogram. Only this set of information is also sufficient, and only this set of information is also sufficient, right? All four of them are true, but if I have to check whether a given quadrilateral is a parallelogram or not, only that pairs of information would be sufficient. Okay, then we also have angle A is equal to angle C, angle B is equal to angle D, right? Angle A plus angle B is equal to 180 degree. Angle A plus angle D is also equal to 180 degree. Angle B plus angle C is also equal to 180 degree. Angle C plus angle D is also equal to 180 degree. Here also, this set of information is also sufficient to tell us that it is a parallelogram. This set of information is also sufficient to tell us that it is a parallelogram. Then we don't need to check anything else, right? For example, this set of information is also capable enough to tell us that it is a parallelogram. A given quadrilateral is a parallelogram, and so on, right? Now we come to the most important part, which is the diagonal property. In fact, for all quadrilaterals, you need to understand that the diagonal property will be more important ones, right? So for example, in case of a parallelogram, if you draw the diagonals, in this case AC and BD are the diagonals, they meet at a point M. One by one, I'll write the diagonal properties. First thing is diagonals bisect each other. In case of parallelogram, any parallelogram, diagonals bisect. Simply diagonals bisect. What does that mean? That means AM is equal to CM is equal to half of AC, right? Then we have DM is equal to BM is equal to half of, BM is equal to half of BD, right? M is the midpoint of both AC and BD. That's what it is important to learn and remember. Now comes the area division. If you look at the area division, that's very important to understand. Every diagonal divides the entire parallelogram into two equal parts. So for example, triangle ABC area is equal to area of triangle ADC, okay, is equal to, in fact, further, area of triangle ABD, yes, and it is equal to area of triangle, which one? BCD. And all of these areas are equal to half of parallelogram ABCD. This is the shorter way of writing two straight lines with GM in the top right corner. Half of this parallelogram ABCD. Okay. Then both the diagonals together divide the whole parallelogram into four equal parts. So area of triangle AMD is equal to area of triangle DMC, okay, is equal to area of triangle AMB, right, or ABM is equal to area of triangle BMC, and all of them are equal to 1/4 of area of parallelogram ABCD. Okay. And then comes the most important part, that is the length of diagonals. So if I say side AD is small a, side BC will also be small a. Side CD, if it is small b, then AB is also small b. And the diagonals, if I call the length of the diagonals as D1 and D2, right? What is the relation of the length of diagonals? It is D1 square plus D2 square is equal to 2 times a square plus b square. And how do we get it? We don't have to derive. We get it from Apollonius theorem. So these are all the properties of parallelogram, right? These are all the properties of parallelogram. Now, before going to trapezium, we need to understand certain things very clearly. There are some children of parallelogram, okay? And those children are very clearly rectangles, okay, rhombuses, okay, and square. We'll take them one by one now. Fine. Let's see. First, I'll explain the formation. How is a rectangle formed? Look at it closely. If I just rotate the side CD and side AB a little bit so that it becomes 90 degree to the side, other side, it will become a rectangle. So rectangle, what is it? What is the fundamental definition of rectangle? It is originally a parallelogram only in which the angles are 90 degree. So everything that we just did for a parallelogram will apply to rectangles also. Okay, so all properties of parallelogram, okay, and some extra property. What are those extra properties? Very important, the diagonals are equal in case of rectangle. So all properties of parallelogram, so whatever we did, this whole thing is, everything is applicable to rectangle also. And extra property will be diagonals equal, and we can also see that if the side is A and B, both the diagonals, I can call it in this case D, and instead of D1 and D2, let's call it D, just D. Okay, so we can say that D is equal to square root of A square plus B square, as simple as that. Okay, that's it, nothing else has to be thought about here. Fine. Now, can we draw a circumcircle on the rectangle? Circumcircle on the rectangle? Yes, we can, right? And what will be the radius of that circle? If I draw the circumcircle, you can see that the diagonal becomes the diameter of that circle. This point M becomes the center of that circle, and the radius will become half of diagonal, as simple as that. Can we draw an incircle in a rectangle? Incircle means, circumcircle means the circle that passes through all 4 points. Incircle means the circle that touches all 4 sides. Is it possible? No, it is not possible in a rectangle, right? Why is it not possible? Because if the sides are different, not possible always. Okay, sometimes it is possible, sometimes it is not possible. I repeat, it is possible to draw an incircle in the rectangle only when all the sides are equal. If the sides are different, then not possible. Okay, so I will rather write it not possible if A is not equal to B. Okay, I repeat, incircle is not possible to be drawn inside a rectangle if the sides are different. If the sides are same, then it is possible because it will become a square. But that is the next part that we are going to discuss. So important thing in rectangle, all properties of parallelogram without any confusion will be applicable, whatever we have learned earlier. And the diagonals become equal. The length of diagonal is square root of A square plus B square. Circumradius of a rectangle is half of diagonal. That's it. In circle, we may or may not be able to draw in a rectangle. That will be a specific situation. Okay.